All right, today we are discussing data structures. We're going to at least start discussing data structures. So, what kinds of data have we learned about so far? What data types have we discussed?
Do you mean like strings and integers, or are those?
Integers, yep. So we've talked about string. We've talked about int. We've also talked about float. And what's the last one we talked about?
Boolean.
Boolean, absolutely correct. So those are all of the data types we have discussed thus far. So what do you guys think that the word data structure might mean? What idea does that evoke?
Like a chunk of data.
A collection of data. All right, yeah. So given what we are currently aware of, how might we store the coordinates of a bunch of points on a graph? I have points on a graph. How might I store that information?
Like an X and Y value.
So just make an X and Y for each one, yeah? Just make it a whole bunch of different integer variables. Sure. So, like I said, you've learned int, float, string, and Boolean. But a lot of information in the world is way more complicated than just strings, numbers, and words, or words, numbers, and true or false. So things like points on a graph. Sometimes we want more than just a couple of integers. We might want to store it in a more efficient way. We might want to store some people's phone numbers and tie that to their name, or maybe even storing a game like tic-tac-toe. A lot of that information can't be stored in those basic data types, so we need something called data structures, which are going to let us collect data in a variety of different ways. So, like Sam said, we could store our data points just in a bunch of individual variables, but this is really it's really big and a little inefficient, right? For every single point I want to make, I need two variables, and if I want to make another point, I need to make two more variables, and so on and so on. So it's not a perfect solution. It'll work, but it's not super great. Wow, look at how ungood that looks. We could also potentially store our coordinates as a string. That will let us store, that'll let us store all of our information for each point in one variable. But then finding the distance is a little difficult. I have my distance equation here. So distance equation is a little easier with separate variables, but that's large and a little inefficient. And it's not very easy when I'm using a string. So there's got to be a better way. And shockingly, I'm annotating. Shockingly, there is a better way. Today we're going to discuss a data structure called a tuple. According to CodeHS, a tuple is a heterogeneous, immutable data type that stores an ordered sequence of things. Now, there are lots of big words there that we will get into throughout today's presentation. And I'll go into more detail about all of this. So here's what it looks like when I make a tuple. I'm going to make a variable equaling 4,1 inside of parentheses. So I'm storing those two pieces of data, those two integers, inside of parentheses. But don't parameters mean functions? And by parameters mean parentheses. Wow, I can't read. I hear you all asking right now, all of you who are on mute on Zoom, everyone in the classroom, are you all asking simultaneously, don't parentheses mean functions? Usually, yes, they would. But there's a big difference between calling a function and creating a tuple, or tuple. There's no right way to say it. And that is, we don't have a name when we are making a tuple. So when we're calling a function, we have to say the name of the function followed by those parentheses with any parameters inside. When we're making a tuple, there's no name in front of those parentheses. We're just making a tuple. We're just using those parentheses. So a tuple can store a whole bunch of values, and it will keep them in the order that you placed them into the tuple when you made it. So if I make my tup equal 5, 8, 2, 59, 9, negative 3, that's the order they're going to be in. Each of those things inside a tuple is called an element. That is the programming word for those things. Those are elements within my tuple. So every element has a unique number associated with it called its index. And an element's index is going to tell us where we can find that element within the tuple. So here are my indices, or indexes. I don't really know what the right plural for index is. So when I'm counting indices, just like many other things in programming, like the range function, we're going to start counting at 0. So the first index is 0. The second index is 1. The third index is 2, etc. So I can find any of these pieces of information if I know what its index is. So that totally works. So if I want to actually grab an element out of a tuple using its index, I can use square brackets after the name of the tuple and then put the index that I want inside. So if I print my tup, and then I'm going to use these square brackets, and then the number 3, so I'm going to say my tup at index 3, what are we going to see output here?
$59.
We will see 59 because that is the element at index number 3. Correct. If I want to grab more than one element from a tuple at a time, we can do something called taking a slice. And this is done by putting 2 indices separated by a colon in these square brackets after the tuple's name. So instead of grabbing just one index, we're going to grab several indices. Like the range function, that second index will not be included, or the element at that index. And a slice of a tuple is going to result in another tuple. So what do we think we'll see when we get the slice from 1 to 5?
$8 to $59, $9.
8, 2, 59, and 9. We're going to start with 1, and we're going to stop before we hit 5, giving us that sequence. And that's absolutely correct. That should be a 9, not the number 4. I don't know what I was doing. Clearly not reading or typing correctly. Notice also that when we print it, we see those parentheses because we are printing out a tuple here. If we want to find how many elements are in a tuple, we can use the len function, len standing for length. Len is just built into Python. We can just use it on anything with more than one thing inside of it. So we can use it on tuples. We can even use it on strings to find out how many characters are in a string. So what is the length of this tuple going to be? It's going to be 6, exactly, because there are 6 elements in this tuple. So len isn't going to give me the largest index. It's going to give me essentially one bigger than the largest index because we start counting at 0. So we're going to have 6 total elements. Just like strings, tuple can be concatenated together. So if I have tup equaling 1, 2, I have tup equaling 3, 4. Tup3 is going to equal tup plus tup. What do we think tup3 will equal?
1, 2, 3, 4.
It'll be 1, 2, 3, 4, correct. So we're gonna just stick those tuples end to end and make one long tuple out of it. Like strings, however, you cannot concatenate tuples with other data types. So I can't just add the number 3 to the end. I have to concatenate a tuple with a tuple, just like we need to typecast to string in order to concatenate to a string. So one feature of tuples is that they are immutable. You cannot change individual elements by themselves. You can completely overwrite tuples, but you can't edit a single piece of information from inside of them. Next class, we'll talk about a data structure that does let you overwrite individual pieces of information. But for right now, with tuples, you cannot change individual positions. If you remember back to the definition, it said tuples are heterogeneous. This means that the types of the elements in a tuple do not have to match. You can have a tuple with every single different type of value in it. I can say tup equals 1, comma, the word 2, comma, 3.0, comma, false, and this is a perfectly valid tuple. And since tuple is a type of data, we can even use tuples as elements within other tuples. So if I make an element in my original tup, another tuple using another set of parentheses, tup at index 4, that's going to be 0, 1, 2, 3, 4. So tup at index 4 is this tuple. And then since this thing itself is a tuple, I can grab an index from that one as well by using a second set of square brackets. So index 0 within this tuple is going to be 5. So when I print that out, I would see 5. Does that make sense? Cool. We can make empty tuples by just putting nothing inside the parentheses. So if I make an empty tuple, open, close, boom, done. Clearly you can't access anything from inside of that tuple because there's nothing to access. There's nothing inside. It's possible to make a tuple with only one element, but you have to do something special. If I try to make a tuple without a comma, with just one element, this is not going to actually make a tuple. This is just going to save the integer 5 into that variable. And that's because parentheses in Python can be used in 3 different ways. We can use them with functions to define our parameter list. We can use them to make tuples, or we can use them to do math. Python is always going to assume we're doing math unless we include a symbol that is not used in math. So if I want to make a tuple with one element, I need to include a comma saying, hey, I'm making a tuple, but with only one element. There's no element following this. So we just need to include that comma to tell Python, hey, this is a tuple. I'm not trying to make an integer here. So if I want to append a single value, if I want to concatenate a single value with a tuple that I already have, we need to make sure that we make that single value into a tuple using parentheses and a comma. Otherwise, we will not be able to concatenate it. Does that make sense? Yeah. Cool. All right, folks. That is our lesson.